Hi everyone, and welcome to the Written Homework 2 Solutions video. So let's get started. Number 1 says your restaurant bill comes to $45 and you want to leave a 20% tip. So A is find the tip. Okay, so we're actually going to do this in a few parts overall. Part A is just finding what is the 20% tip. So all we have to do here is take our $45 bill. Okay, and to find a 20% tip, we're really just saying what's 20% of this. So we multiply by 20%, which remember, whenever we get a percentage like this and we want to multiply, you just move the decimal place twice. Right? So if I have 20%, got my decimal place, I move it twice, that's 0.20. Okay, so let's plug that into our calculator. We'll move it over here so we can see it. 45 times 0.2, that's $9 tip. So we have a $9 tip for part A. Okay. All right, so then now part B says, okay, how much are you going to pay? When all is said and done here, how much are you going to end up paying? Well, we're going to pay a total of $45 for sure. Right, that's what our bill was. But we also want to pay the tip, which was $9. All together, that's $54. We added. All right, this is kind of some of the way you guys attack, which is perfectly fine, percent increase. You say, okay, what's my start? You take the percentage, and then you add that on top. Great. All right, so here's the extra credit piece. We'll see how many of you got this. How can we do this without a calculator or a pencil and paper? So what do we want? We want a 20% tip, right? This is our goal. And so here's the trick. I say 10% tip. That's the key. Well, a 20% tip, that's really a 10% tip plus 10%. 10% plus 10% is 20%. And we know something about doing 10% of a number. 10% of $45. What's our trick here, right? When I do 10%, all I have to do is take my decimal place and move it one time. That's 10%. So that's my little trick. So, okay, I use my little 10% trick, and I know that $4.50 is 10% of my bill. All right, so then how did I get to 20? Well, 20% is just two of those. So if I want to get to 20%, all I have to do, 20%, is I take 10% tip plus 10% tip, which was $4.50 plus $4.50, which is $9. Okay, so I know that I just did that like pencil and paper, but you don't need it because in your head, here are the steps. Step 1, move the decimal, and we can do that in our head, right? You just move the decimal in your head. 45 is 450, and then step 2 is double it. So these are your steps you can take. And I'll admit, sometimes the bill, the number you get, can be a little weird and it's hard to just double. But in situations like that, just round. So if instead, just as kind of like a side example, so just like a side little example here, if you instead did, your bill was $47.93, well then 10% of that is going to be $4.79, right? And so then in your head, doubling that can be a little bit tricky. So yeah, I get it that it's a little tough sometimes to do these in your head, but you can always round a little bit to make it nice on yourself. Lots of ways to kind of think of this, but that's it. Move the decimal, double it. Boom, you've got 20%. And you can show off to all your friends. Okay, number 2. Let me give myself some space here. the grocery bill this week is $125. This is a 10% decrease from last week. So what am I saying? I'm saying right away I did percent decrease. So just right off the bat, I even see it right here, right? So last week I had a bigger bill. This week it's smaller. That's percent decrease. So big, big, big. Okay. So if we're going with the format of the study guide where I showed you all those ways to just use that one formula, I'll write the formula out. Y equals X times P. Okay. Y, remember, is your new number, right? That's like your new. X is your old number. And this P has to deal with the percentage. But it's not quite exactly the percent every time, but it deals with it. So then how do we do this? Well, let's just plug in what we know. Our new grocery bill is $125. Okay, awesome. That's equal, we don't know last week's, that's our old, right? We don't know the last week's bill, so we don't know that. That's what we got to find. Times, and then here's where we have to be sneaky. We've got to remember how to do this. Percent decrease. How do I figure out what goes for P? Remember what I do. 100% is where I'm not doing anything. I'm just 125. It would be the same. But then I decrease 10%. That leaves me with 90%. That's my P. So remember, whenever you do percent decrease, you could take 100% minus whatever percentage you want to take away because it's decrease. That tells you what percentage is left. And that goes in for your P. So remember, it's crazy. This one formula, all these different examples. Okay, so then how do we actually solve this, right? So then we have to actually solve this. Remember, we do 125, I'll just rewrite it here, X times 0.90. And then remember, the goal here is to get X by itself. So when you're doing this, remember how this works. X by itself means I got to get rid of this 0.9. It's attached using multiplication, right? So then how do I get rid of this? I've got to do the opposite of multiplying. I have to divide. And don't forget, you do something to one side. Balance, balance, balance. You got to do it to the other. So what ends up happening? Cancel, cancel. And we're left with, altogether, 125 over 90, or sorry, 0.09 is X. Let's grab our calculator, clear things off. 125 divided by 0.9 is 138.88888 forever. How about we write instead 138.89? And don't forget, we're talking dollars here. That was my bill. I rounded to 89 just because when we're usually talking about dollars, we usually stop at the second decimal place because that would be cents. So that's a perfectly fine thing for you to always do. So my bill last week was $138.89. Okay. So number 3, tricky problem, right? This was one of the trickiest ones on the whole homework. So I said, okay, here's the problem. You get a 5% raise at your job and you now make $50,000. So that's your new number, 50,000. So we can even write that down, right? That's our new number. Okay. Now, 5% raise means that this was percent increase. Okay. I'm interested, what was your salary before the raise? Okay. So here is the fake wrong solution that I wrote down. 50,000 times 0.95 equals 47,500. This is the wrong solution. This answer is not correct. And to understand why this isn't correct, okay, first things first, my 50,000 is in the wrong spot, right? The new number, if you're using my equation, the new number is supposed to go here. So it's in the wrong spot. So that's one thing that you can immediately say, uh-oh, something's wrong with this equation. But more importantly, what's wrong with this equation is this is telling me right here, this 0.95 decrease. This here, right here, says decrease by 5%. And I know that that is an intuitively correct sounding thing. We had some money we made. We went up 5% to get to this new number. So how do I figure out how much I made? Well, let me just go back by 5%, right? That's something in our head I think is okay. I think it's okay for you to have that intuition. You're used to it. When we're adding and subtracting, it does work that way. But this does not work for percentages. If you go up 5%, you can't just go down 5% and get back to the same spot. It doesn't work that way. So this is trying to do that, up 5%, down 5%. No good, okay? So let's write that down, and then we'll show the real solution. This solution tries to undo a 5% increase by doing a 5% decrease. This is incorrect. Okay. So let's actually do the correct one, and you'll see that we get a pretty close number, but we still get a different number. So I didn't ask you to necessarily do this. I just said, tell me what's wrong. But, you know, for completeness, why not? Correct solution. Okay, so here we go. Correct solution. So let's think about the setup again. My new number's 50,000. My old number, I don't know. I did a 5% increase. So let's put in what we know. My new number is 50,000. My old number I don't know, times, now this number that I'm going to put in here has to deal with percent increase. Remember how we do this P. Remember how we get P for percent increase. 100%, that's just, I didn't change, right? But I want to increase, plus my 5%. That's 105%, which makes P 1.05. Okay, so let's erase this P and let's throw in 1.05. All right, so then we have to get X by itself, but again, that's very similar to what we just did, right? Not too bad. Let's change our colors up. We're multiplying here. How do we get rid of that? Well, we've got to divide. Cross, cross. Balance in all things. Divide on that side. All right, let's do it. 50,000 divided by 1.05 equals 47,619, and I'll round to 5 cents. 47,619 and 05 cents. Here you go. So you'll see, right, that when I did this the incorrect way, I accidentally overshot when I tried to go down 5%, which hopefully makes sense. Increase 5%, you get a bigger number, right? So then when you try to go down 5%, you're going to take 5% of a bigger number, which means that chunk, that 5% chunk you're going to take away, is bigger than the 5% chunk you had added to start. So that's the key. Doing 5% to different numbers is going to give you a different chunk when you're adding or subtracting. Okay, so that's what you got to be thinking about. That's why it does not work to just go back down 5%. All right, so let's check out number 4. You're at a clothing store and find a shirt you like on sale for 30% off. Let's go back to blue. There is no price tag. Oh, geez. You check out, and after the 30% discount, the price comes to $13.99. What was the original price? All right, so let's give ourselves some room here. All right, so this is pretty similar to what we've already done. So a couple things to notice. Discount, right? We're taking the sale. We're doing a sale, right? See that word here? So this is going to be percent decrease. Okay, so it's something to just pick up on. All right, so it says after the 30% discount, the price is $13.99. So our new number is $13.99 equals the actual original price of the shirt. This is what the tag would say. And then 30% discount. How do we figure out what P is? Remember, 100% minus 30% gives me 70% left. That is a P of 0.7. Same process as before, right? Multiplying, how do I undo? I divide. Okay, let's plug this into our calculator. $13.99 divided by 0.70 is $19, and we'll round 99 cents. Do a little rounding here. This gives me X. My original price is $19.99. So before the discount, it was $19.99. Woohoo! Okay. B. Toughie. You realize you have a $5 off coupon for the store. Is it better for you, not the store, you, to have the $5 coupon off before or after the 30%? So let's recap what we're going to do here, right? So what are our discounts? Let's put that in the corner. Discounts. We have 30% decrease. So we're going to go down 30%, and then we're also going to do just a flat minus 5. So these are our two discounts. So we have two options here, right? Option 1. What's option 1? Option 1 is percent first, then $5 off. Or you do the $5 off first, off the price, then you do the percent. These are not going to be the same thing. One is better for you, the customer, than the other. And it actually is partially related to what we talked about in the previous problem, the real toughie. So you're going to take 30% no matter what. But here's the thing. 30% will change if the number you're applying it to changes. So $5 off is $5 off is $5 off. $5 off, it doesn't matter if it's a $100 shirt or if it's a $1,000 shirt or a $10 shirt. $5 off is $5 off. But 30% decrease or off or sale, however you want to say it, that's different. That's a different amount of money if it's a $5 shirt, a $100 shirt, a $1,000 shirt. And so here's the thing. We want to maximize this percent decrease. So when we apply the percentage to this shirt price, we want it to be as big as possible. Okay? So how do I get that? Well, that tells me I have to go with number 1. So let's do an example here so that you can see that number 1 will be best. Okay? So you could try thinking through the explanation the way we just said it, but just go to example. Always just get yourself an example to see what's going on. So let's do the shirt is $50. $50 originally. Okay, so $50 shirt. $50 shirt. Okay, so $50 shirt. So let's do number one, right? What does it say? It says percent first. So the first thing we're going to do is a 30% decrease. Okay, how do I do that? Well, I take my original amount, I multiply by 0.7. Remember, 30% decrease, 100% minus 30% is 70%. Okay, let's see what we get there. Whoop. 50 times 0.7 is $35. Okay, so after my 30% decrease, my shirt price is down $35. Okay, that's nice. Now, step 2 in this, apply. So here's the first thing we do, second thing we do, apply the $5 coupon. $35 minus my $5 coupon is $30 total. All right, so I do my percent, then I apply the coupon. I only pay $30 out of the original $50. All right, so cool, that's good. What about the other way? Let's try way number 2. So that is apply coupon first. So let's do it. So let's apply the coupon. Okay, so we apply the coupon. We do 50, because that's our start, minus 5 to give me a $45 price. Then we apply the 30%. How did we do that? We take our 45 and we multiply by 0.70. Remember that calculation we did up here, right here. Okay, and we're going to need our calculator for this. 45 times 0.7, $31.05. Let's compare. What's better for you? Hopefully that doesn't take too long. I only want to pay $30, not $31.50. $1.50 is $1.50. I want to save money. So way number 1's better, okay? And so here's the idea. If you're still kind of thinking here, I don't really see it, here's where you got to focus. This step and this step right down here. Okay, so what's really going on here? Well, way number 1, when I apply the 30% decrease, I end up taking off $15. 50 to 35. 50 to 35. So in way number 1, when I do the percent first, I end up getting to knock $15 off the price. But what happens when I do the percent second? Here, I don't knock off $15. I knock off less than that. How much less? Well, I go from 45 to 31.5. This is only knocking off $13.5. So, applying the coupon, $5 off both times, doesn't matter which way I do it. Applying the percentage, I actually take off a different amount depending on the order you do things. There you go. So you've seen an example of this. Try to wrap your head around it. Overall, the kind of things we've seen here are the order you do things matters for percentages. So you've got to really be thinking about what it means to do a percentage when you're doing these things. Okay? So really you got to think about these things when you're using it. We'll be dealing with percentages more later, so we'll get a lot of practice with this. So just try your best, learn from this, and apply it to the project and everything going forward, whatever you fix if you needed to fix anything.